Hello, I'm Héctor Cadavid, and in this video I'm going to describe the key findings of our survey on the interplay between software engineering and systems engineering during system of systems architecting. And I would like to begin explaining why are we exploring the architecting process of system of systems considering the relationship between these two disciplines. So it is worth noting that most of the actual system of systems out there are the ones created in domains like defense, energy, aeronautics, which, due to the number of disciplines that they have to deal with, are in most cases governed by a systems engineering process. On the other hand, it is well known that in the systems created in these industries, particularly the system of systems, software is a pervasive, critical, and abundant element. And on top of that, it is known that the relationship between these two disciplines is still not well understood and is in some cases problematic. In fact, it has been reported that when you try to combine the practices from these disciplines, it sometimes leads to gaps or mismatches on its application. So in this survey, we are exploring the challenges perceived by practitioners and researchers when working on the architecting activities on system of systems, of analysis, synthesis, and evaluation, but from the point of view of the interplay with each other discipline. That to say, in the activities of analysis, synthesis, and evaluation that involves the interplay between systems engineers and software engineers. Furthermore, this survey explored the challenges also related to the interplay between these two disciplines when dealing with the challenges of emergent behavior, desired or undesired, and the autonomy of the constituents of a system of systems. In this case, the survey was conducted online, and it was conducted between December of 2019 and February of 2020. We got a total of 76 responses after sending a total of 335 invitations. And we've ended with a total of 16 valid responses. As you can see in this graphic, we have a good distribution of people with a background in software engineering, software systems engineering, or people with both backgrounds. We have our population sample includes the application domains we have just mentioned, and for the most part, most of the participants are from the industry, as we can see here. Now, moving to the key findings and regarding analysis, we found a series of issues related to the way system level requirements are translated into software level requirements. In particular, systems engineers mentioned that the lack of domain knowledge of the software engineers often led to the misinterpretation of the system requirements. But on the other hand, we found that software engineers often mention that system level requirements are either unclear or incomplete. Furthermore, we found that at both levels, there are often assumptions on related to requirements. That to say, at system level requirements, there are some details that implies an assumption about the software level requirements that has not been agreed with the other part. Regarding synthesis, that's to say, related to how the architectural decisions were made at system and software level, we found that in many cases, the architectural decisions at software and at the system level are made separately and independently by teams of system engineers and software engineers. And this intuitively seems to be problematic, but this also means that in many cases, the practice of co-architecting is not being adopted. Now, regarding evaluation of the architectural decisions, we found that when it comes to the evaluation of the architectural decisions at software level, in many cases, these are not evaluated against the software requirements. Instead, some of them are considered as implicitly validated if the system was already validated. That's to say, if the system works well, that was assumed that the architectural decision at software level were okay. And in other cases, the architectural decision at software level were validated against a set of higher level system level requirements. That could be seen as the validation of architectural decisions at software level have lower priority when compared with the system level architectural decision validation. Now, regarding emergence, we found that emergence, that is a really important topic in system of systems. We found that according to the respondents, a common cause of the undesired emergent behavior are those elements that are not included into the modeling and simulation approaches due to its scale. More specifically, we're talking about the low-level hardware components that, due to the level of granularity of the modeling and simulation approaches, are not considered on them. Now, regarding the challenges posed by the characteristics of independence of the constituents of the system of systems, we found that the problem of unclear and incomplete interface specifications was a common theme at both integration and up to the evolution phase of the life cycle of the system. That basically means that this particular problem could be seen as a cause of technical debt in system of systems that is carried from the integration up to the evolution. It was interesting, though, that another common problem that emerged as a theme in the surveys is the insufficient interface specifications management. This is interesting because these two are seemingly related, and we could argue that by addressing the problem of insufficient interface specifications management, we would be addressing to some extent the problem of unclear and incomplete interface specifications. Now, I would like to conclude with the main takeaways of this presentation and this study. The first is this important to note that some of the problems that were mentioned and were discussed in this presentation has been already discussed in the literature for a long time. For instance, the problem of the lack of domain knowledge of the software engineers when they are involved in systems engineering projects has been discussed for years. But this basically means that these particular problems, despite being already reported, are persistent. And this could also mean that there is a gap between research and practice in this particular area that is worth to be further explored. Second, we believe that one of the findings of this study, the one related to the elements that are not be considered in the modeling and simulation and that are actually being one of the causes of undesired emergent behavior, is particularly important for the community working on research on approaches for identifying or anticipating undesired emergent behavior through modeling and simulation. And third, we believe that the last key issue we presented here, related to the problem of insufficient interface management and its related issue of incomplete interface specification is a key topic to be explored and could be the key element to some extent harmonize the practice between these two disciplines. As a future work, we are indeed exploring harmonization practices in the context of system of systems between system engineers and software engineers by exploring the practices that some of the practitioners that have already created system of systems despite of all these problems have came up with. So that's about it, and thank you so much for your attention.